Hello, everyone. Today I'm going to talk about a data warehouse system that was developed at Google. My name is Jagan Sankaranarayanan, and I'm presenting on behalf of my Google colleagues. All right. Now, data warehouses design has been typically skewed by these so-called white whales. So these white whales require faster, better, larger, higher ingestion, greater freshness, and in short, performance at any cost. Now, the newer clients, of course, cannot pay for performance at any cost, and they have fairly sophisticated performance characteristics, which are quite hard to achieve using the traditional design. So what we did is we built a new data warehouse design called Napa. This is a data warehouse that is suitable for many workload types. Napa as a system, at a very high level, consists of three components: the ingest, the storage, and the query serving. An ETL pipeline brings in a tremendous volume of data, several trillions of rows per day. The way to think about it is that any minute, every second of the day, we have tens of gigabits of data, of compressed data flowing into the system. It's planetary scale, widely available. The key aspect of Napa, however, is that we have sort of bet the bank on materialized views. Every table has hundreds of materialized views. These are indexed, sorted, consistent with the root table, consistent across cells, and they are able to serve queries at sub-second latency, billions of queries every day. The users build their own dashboard, analytical tool, widgets, or collabs to talk to our system. And these are fairly interactive applications. So which basically means that they need sub-second latencies. The key realization here is that sub-second latency obviously is a good goal, it's a right goal. But more importantly, what is necessary here is the notion of robustness. That is, that there's a low variance in the response time between one query and the other. It would make for a terrible user interface if queries take several seconds in one attempt and it goes much faster the second time. Now, that is easily said than done, for the fact that the workload is constantly changing, the ingestion is changing, and we don't, and unlike other database vendors that require data warehouse to run on custom high-end, high-performance hardware, we run our data warehouse on internal Google Cloud, which makes it very hard to tame variances. The second realization here is that what is more important is that the clients require flexibility. Not every application that they develop require millisecond latency. Not everything requires minute freshness. Not every application has unlimited data warehouse budget. You're talking about clients whose business model is constantly changing. So what they do is they come back to us and say, I want to rebalance my performance, rebalance my cost, rebalance my freshness. I want more cost, less cost, more performance, less performance, more freshness, less performance. Imagine running an infrastructure with hundreds of these clients who are constantly changing their requirements from the data warehouse. You need a data warehouse that's able to provide such flexibility. Let me give you three examples. Here, a cost-conscious client runs an experimental framework, comes to us and says that cost is super important to control. We need good performance because our clients do interactive analysis, but I'm willing to sacrifice on some level of freshness. Another client comes to us and says that we serve fresh analytics, so obviously we need high freshness. Cost is very important to us, but we are willing to take a hit on query performance. A third client comes to us and says that, we are external facing, we are super important, we are very visible, we need great query performance, we need high data freshness, but we are willing to take a hit on cost. We are able to pay a little more cost. As you can see, we get clients from every end of the spectrum, and these are constantly changing too, and you need a system that will actually be able to evolve with the client needs. Now, flexibility is hard to achieve. Client flexibility is quite hard to achieve, and we can actually show it by if you look at two popular designs. One is that couples storage with ingest, and the other design that couples storage with query serving. In the first case, the problem is that if you want good performance, you have to sacrifice freshness. And in the second case, where you couple storage with query serving, you can get great freshness, but you have to either give up on query performance or you have to give up on consistency. As you can see, there is no free lunch here, right? So the choice is already made for you. What we came up with in Napa are two key changes to the traditional design. Our warehouses, which we show on the right, still consist of the three same framework: an ingestion, a storage, and query serving, except that they're decoupled from one another, which means that each of those components can go as fast as they can. The brain of the system is what is called a controller that controls the state of the system constantly. It keeps the system in the sweet spot that corresponds to the user requirement. The key trick here is this notion called a queryable timestamp, which I'm going to describe next. The queryable timestamp is a notion by which what is queryable by the client actually lags by some time in the past. The clients can query the data up to what is called the queryable timestamp, which is typically 5 to 25 minutes in the past. Now, multiple conditions influence the QT. For example, all the views should be generated, the number of deltas that the client needs should be less than X, and the data should be replicated in all data centers. I'm going to just focus on one aspect of it, which I have highlighted in red. The system is constantly being pushed and pulled. One push in one direction is the ingestion. The more you ingest or the more data comes in, or if there is a spike in the data, it actually makes the table and database less fresh. Indexing improves the freshness of the thing by actually updating the views and indexes. Regardless of these push and pull, the client always opens the same number of span. But if you don't act on it, the freshness delay keeps increasing. What the QT does is it basically maintains the thing. It invests resources where it needs to be invested and makes sure that the client gets what they are paid for. Let's go back to the three use cases. As you can see in the right-hand frame, that we have already provisioned some indexing, some ingestion, and some cost. On the left-hand frame, we actually have figured out what the span the thing should be maintained in. Given these kind of input configuration, the database system will actually maintain all databases, tables, views in the right performance characteristic. This is how clients are able to get exactly the kind of requirements that they need. Very quickly about the infrastructure, one novelty about what we have done here is that we use a database system both for processing the data as well as serving the query. We use our infrastructure called F1 query, both as a data pump to transform petabytes of data, as well as to serve these queries that touch just a single row or a few rows to be able to serve queries in a very short amount of time. Now, about client queries, how the robust query processing is achieved by actually using a service that sits between the actual worker and the scan and the raw disk. The paper talks about multiple of these strategies. I'm going to just give 3 of them. One is that you want the queries to bind to the right view as opposed to the table. You want to be careful how many deltas you open and merge during runtime. And then we cache as if our life depended on it. We cache the metadata, the distributed cache, and so on. We prefetch and we do a bunch of these tricks. The paper talks about lots of different experiments. I'm just going to talk about one of them. So the following graph shows the clients from before, and let's just focus on the blue curve where they have traded off freshness. One can see that they get a heavy ingest load, they get moderate performance, the cost is quite low considering how much they push, and they are also able to get low freshness. Similarly for the other clients. To summarize, Napa is comparable to other systems in the sense that we handle massive amount of loads. We are very different in the sense that we provide flexibility to clients in terms of freshness, latency, and cost. We maintain views consistently and we give robust query performance. Our design is very unique in the sense that we provide ample opportunities for automation and self-tuning. We will describe them in a future paper. Thank you so much for your attention.